All right, we got some answers. We're going to talk about all of them, okay? Let's see, maybe you can answer your own question. Let's see. All right, here we go. What did we get for the first one? The analytical rate of change. And remember, you write down what I told you to write down before you start in on the problem. So for this one, you're gonna find f of 3 minus f of negative 2 and divide by 3 minus negative 8. All right? So what did you get for f of 3? Be careful. F is a piecewise function. And that means that it has different definitions depending on the input variable. So we use this definition if our x is less than or equal to 1. If we are plugging in 3, will we use that definition? No. We have to use this definition if our x is a number bigger than 1. So, what's f of 3? F of 3 is 10. Does this make sense to everyone? So that's going to be 10. Now, what about negative 2? Now, negative 2 is less than 1, so we'll use that definition. So what's f of negative 2? Negative 8. I got 18 over 5. What about you? Everybody good? Okay. All right. Now, graphical, that's another piecewise function, but it's got pictures. The first thing you should have written, g of 9 minus g of negative 3 over 9 minus negative 3. Okay, so that needs to be written on your paper. Okay, what's g of 9? Look at your picture. G of 9 is 3. And g of negative 3 is negative 2. So I got 5 over 12. Good? All right, and then for the next one, you wrote, before you started, h of 7 minus h of 2 over 7 minus 2. This was a chart. So what's h of 7? Negative 4. And h of 2 is 3. So did you get negative 7/5? And then what in the world did you do with that last one?
I'm only scared.
Perfect, we get your question there. All right, what about that last one? What was your thought? No thoughts? I need your no thought. Well, what is your thought?
Well, I didn't do it, but I thought you put it in point slope for you.
Okay, so Will says this is a line. It says linear function. Average rate of change, aka slope. So I have an equation where I know the slope is negative 3 and the y-intercept is 5. Isn't that my equation? They handed it to me. Now, what is the x-intercept? Well, how do I find, what is it? X-intercept means y is 0. So we put in 0. And it looks like my y-intercept is 5/3. You okay?
Where did I mess this up? Oh.
The math isn't hard, the words are hard. The words make it tricky, though. The math is easy. You good with that? Okay. I have one correction to make, at the very end of the period, and I don't know what I was thinking, I don't know what I was thinking. But I need you to get out your 1.1 homework, which I have returned to you if you turned it in. And I told you bad information, so I need to just make sure we're clear on it. So problem number 2, you're given a table of values, and I'm not gonna plot them all, but for a negative 4, 3, negative 1, 4, 0, 4, okay, and I will plot them all, 2, negative 2, 3, 1, and 2. All right, so on the second problem, on the 1.1 homework, we had one exactly like this in the notes. And I, for whatever reason, connected the dots. They should not be connected, all right? That's I told you to, and I was totally wrong. These dots should not be connected. Why? Because I have absolutely no idea what happens between 0 and negative 1, for example. That could be a point clear up here, or a point clear down here. I don't know, I can't connect those. So those should just be dots. Now, why are those dots, but one should be connected? Because number 1 doesn't list a table of values. Number 1 gives me an equation and says for every number in this interval, f doubles the input and subtracts 1. For every number in the interval. So I can go ahead and plot some, but then I'm going to connect them because it's every number in the interval, not just the table of values numbers. Do you see that distinction? All right, I apologize for that confusion. Number 1 should be connected. By the way, this is a line. Should there be arrows on the end? Some of you put arrows on the end. No, because aren't we given a definite start and stop point? We're starting at negative 3 and stopping at 3. So you should connect them, but it should be a segment, not a line. Okay? So there they're connected. Number 2, they're dot, 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 dot for number 2. Okay? All right. Let's go back to our notes now and do a little bit more work in our notes. And then I'm going to hand back you the quizzes. So you can spend some time going over those. Okay. So yesterday we were on the back side of what's Pamela's current speed. And we only got through the first one. So what I'd like to do, so we're on the check your understanding on the back of the page called Pamela's current speed. We did 1A already. I want you and your partner to finish the page and come up and put your work up here so that we can figure out what you're doing if you're writing the wrong way.
Oh, right. Okay, genuinely, I just took the games there. Oh, we did. You guys didn't put it out. Oh yeah, that's what I was saying. Want me to do it?
I'm not sure.
Our method is a decreasing rate of change. Yeah, but like, just sensitivity.
You got it figured out,
Yeah.
let's get them up on the board. You done? We'll put something on the board.
So, just go up there, just like,
You want to do A or B? We're doing. Do we just do all of one?
Well, one we already did.
Oh, we already did that?
We already did A, so we all right, 1B and 2 are being down on the board, so I still need 3 and 4 A and B.
that's what I immediately forget. Because I felt
If you get stuck on one, keep going. Just skip it and go on.
we're just and then plug the English one in, it's 1. And the square root of 1. That's what I got. Oh, okay. So should I learn?
I didn't listen.
Yeah, I'll check. That's great.
Wait, first question.
Because it's what's higher, square root of 12 or 4. What's the square root of 12?
And that's his first. Oh.
Yeah. Or like it when I have 0, it's fine. Which is the
What is this? Why is there an arrow?
I don't even really
Why is there?
yeah, exactly.
Did you guys get 2? All right, let's talk about these 2. And we'll erase them and we'll get the rest of some more of these to come up. Number 2, let's look at number 2 here. Find the average rate of change from the interval from -1 to 4. So she wrote down her average rate of change formula, here it is. She plugged in numbers and got 4 and 1, perfect. 3/5. How does that look? Did anybody get to that problem? Okay, good, that looks good. I like it. All right, this guy, question says, this is 1B. So let's see. We had done part A already, if you remember that from before, and we'd gotten that the average rate of change on the whole interval was negative 2.3. So he said my slope is negative 2.3, my y-intercept is 66. How did he know that? 0, comma. So here's the equation of my line. I'm going to plug in 3.5, and I got this. Now, that is 100% true. Does that answer the question? What was the question? This would be the answer to what is the temperature after 3.5 seconds? Or minutes, whatever it is. What was the question? What's the rate of change? What's the rate of change? Okay? So, anybody have a thought on that? First of all, his creation of this line was great. You need to be able to do that. We did that on that worksheet a minute ago. That's perfect. It just isn't what we need to do this time. What ideas did we have? Yes, Audra.
I did two, like, in the
Oh. So Audra said, I'm gonna find the average rate of change from 2 to 5. So f of 5 minus f of 2 over 5 minus 2. It might not be f, it's h. And so that was what? 52 minus 60 over 3. And that turned out to be negative 2.67. What is your thought process there? Here's 3.5. Right in the middle of 2 and 5. So if she said, if I find the average rate of change from 2 to 5, that might be a good guess for the one right in the middle? Yeah. I love it, Audra. Good job. Anyone have another thought? Come on, you gotta think. You gotta have thoughts. All right. I need 3 and 4A and 4B up here. Who's got them? Let's go. Yeah, 3, 4A, 4B.
Yeah, well,
Which is 4B. All right, 4A's taken. I need a 3 and a 4B. You do 3? Perfect. He's doing 3. 4B. You do 4B. Then you have it will be signed. So this is a positive. If you wanted an A, it will say. Now, if you're solving an equation, then you have to start if the radical's already there, it's whatever sign it is. If you're putting it in, then you have to do plus or minus. Okay?
What's the difference between regular?
out his little formula and got 2. How does that look to everybody for 4A? Looks great. Noah, does that look great? Okay. All right, let's talk about 4B while Will's up there doing the stuff he's doing. The average, I gotta compare these things. I don't have to find them necessarily, I just have to compare them. So what can you tell me about the average rate of change from 0 to 3.5? Now remember, that would be, what is this G? So that would be G of 3.5 minus G of 0 over 3.5 minus 0. Would you agree with that? What can you tell me about that? You can actually figure that out, but would you agree that's going to be a positive number? This is positive, G of 3.5 is positive, and that's just 0. So this is going to be positive. Okay. Now what about the instantaneous rate of change at 0? Now remember, we talked about this yesterday. The instantaneous rate of change is the slope of the tangent line. So at 0, at 1, aren't we at the maximum?
Yep.
So when you draw a tangent line in, it's going to be, the slope is going to be 0. So part A, or the first option here was a positive number. This is option 1. Option 2 is 0. The rate of change is 0. All right, now how about from 1 to 3? Now the average rate of change from 1 to 3. You can either calculate that, or you can look at your picture, you guys. 1 to 3 is connected. What's happening? It's going down. Isn't the slope going to be negative? Your rate of change is going to be negative. So whatever it is, it's negative. And then the instantaneous rate of change at 0.5. So imagine drawing a tangent at 0.5. What can you tell me about that tangent line, about its slope? It's not just positive, it's quite positive. It's very steep. So it is a big positive. So now I'm arranging these from least to greatest. Well, this is the least because it's negative. And then this is next least because it's 0. This one would be next least because while it's positive, it's not as positive as that one. The slope at 0.5 is nearly vertical. That is very, very steep slope. Does that make sense to everybody? Okay. And then, oh my gosh, we totally love Will because he said, yesterday, Mrs. Ford told me that if I wanted the instantaneous rate of change, I had to find the rate of change on a smaller and smaller angle. And look what he did. Awesome. You're a hero. I did not do that. I am not as ambitious as Will. It's beautiful. And right answer, same answer I got. Let's think about this for a second. Do you guys know what this equation looks like? Just in general, not, I don't need like specifics. What's it look like, Sampo? I saw your hand moving.
Okay, it's like, I don't know how to, it's like starts going up a little bit and then just kind of like flies.
Exactly. Now this one is going to be shifted, whatever. But in general, a radical looks like this. Now this one's over here, it's been shifted. The curvature's a little bit different. But that's the shape of it. what happens to the slope, positive slope, but what happens to the slope the farther out on this curve you go? It flattens out. So it stays positive, but it gets smaller. With that function, you're always going to get small, as long as it's not negative or something. It's always going to get smaller as you go out, right? So the question is, what's higher? The slope here or the slope out here somewhere? Obviously, it's going to be at 0. The closer you are to the beginning of the picture, the steeper your slope is going to be for that particular curve. Does that make sense to everybody? Will, I totally love what you did. Good job. Good job. All right, now I'm going to hit pause for a second, and I'm going to hand back your quizzes. And Lydia got a perfect paper, so you can